Great. So if you'll remember me, Colin McCarthy, Specialist Solutions Architect at Red Hat. So specialized in Ansible, um, but also covering emerging technologies like OpenShift and Quay. And we wanted to show you a new feature that Ansible has in tech preview right now. It's actually not fully like supported yet. It's just in a tech preview type stage, but it's called container groups, and it's pretty interesting. What it will allow you to do is actually run Ansible playbooks in pods on Kubernetes. But I do have just a couple slides to get us started here. So, we're still going to be talking about the Red Hat Ansible Automation Platform today. And when I say platform, that's because it really has evolved, from Ansible Engine to Ansible Tower to Ansible, software as a service offerings, right? So there's sort of three pillars that exist today. You have Ansible Engine, which is still the engine that's running the automation. But then you have Ansible Tower, of course, which is the enterprise framework. But we also do offer now some software as a service features that are available to you, right? If you choose to turn those on, you can do things like analytics, or you can have a service catalog that can be found at cloud.redhat.com. And of course, Tower still has the features that you're used to, right? So you can build and manage dynamic inventory, still has role-based access control, workflows, all the great stuff that you've been starting to use. Has that great RESTful API, right? But what I want to talk about today is the container groups. So like I said, what it's going to allow you to do is launch your playbooks in pods on Kubernetes, right? So it's a true Kubernetes integration with Ansible Tower. So it allows you to fill out a pod definition file. When you're dealing with Kubernetes, the smallest sort of object that you can launch, right, is a pod. That pod is defined by a pod definition file. It's written in YAML, kind of, just like an Ansible playbook would be. And what it allows you to do is define an image, right, a container image, and then also some specifications that go along with that container image. So it's really kind of the beginnings of Kubernetes. When you start to learn Kubernetes, that's probably the first thing you'll learn is how to spin up a pod, right? A pod can contain like one or many containers, but sort of the smallest thing that you can spin up is a pod, right? And so that's what we're going to talk about today. Is Ansible Tower is actually going to spin up a pod on Kubernetes, or in this case, OpenShift, to run the Ansible playbook. So yeah, let me just do a quick summary then of Docker, right? So Docker is the kind of container runtime that kind of is most popular probably right now for running containers, right? And so the way that you would build your container is you would use a Docker file, and this slide that I'm showing you right here has a good example of a Docker file. It's actually pretty simple. So I'm just using from, and I'm using kind of what you would consider a base image here. And typically that's what you would do, right? You would say from, Alpine, or from Red Hat 7, right? RHEL 7, or from CentOS 7, right? Something like that. And then you would start to define, what's going to be special about your container. So in my case here, what I've done is I've crafted a base image, and I'm actually hosting it on quay.io. So we're going to talk a little bit about Quay today as well. So Quay is Red Hat's container registry, right? So there's a software as a service version of it, and that's kind of what I'm using today, right? So if you were to go to quay.io, you would see it, and if you're familiar with Docker, you've probably heard of like Docker Hub, and that's a container registry, right? So Quay is Red Hat's sort of flavor of a container registry. Now, in production, you would host this on-prem, and most of the time you would be hosting it, on Kubernetes itself. There's actually 3 Quay Kubernetes operators to install Quay, and then also to do things like integrate it into OpenShift. So you can do things like the bridge operator, or you can do the Quay container security operator, which will actually integrate the ability from the OpenShift dashboard to actually look and see if you have any vulnerabilities in any of the containers that are currently running on OpenShift. So in my case, I'm just using the website quay.io to host this, right? So I didn't spin up Quay on Kubernetes, and I'm not hosting it like on a cluster here. But what I did was I created a base image, and I did that from Ansible Runner. And Ansible Runner is really what's going to make these container groups possible. So I have my base image, right? So I control that. So if there's any updates with Ansible Runner or anything, it's not going to affect me unless I go and update my image, right? So what I'm doing here is I'm controlling the software supply chain, right? Now, I have that base image, but if you're familiar with Ansible and you've started to use Ansible, especially, Ansible Tower, then you probably realize, like, if you have a certain set of modules that you want to run, you have to look and see what dependencies are required for those modules, right? So there's Python packages that most likely need to be installed. Cool. In my case right here, I like to create ServiceNow tickets with Ansible. And so there's a dependency that's required there, which would be the PySnow Python package. And so that's what I'm doing here is I'm taking my base image, and then I'm installing my dependency with the run pip3 install PySnow, and then I specify the specific version, right? Because I'm controlling the software supply chain here, right? I want to be very specific on which version I want installed, right? It's against best practices to put something like latest or something in there. You know what I mean? You really want to be in full control there. And then that third line, the command, Ansible runner, run runner, that's just required for these container groups when we're using Ansible runner. So a lot of this will make more sense once you see the demo and you see this in action and kind of see how cool it is. But that's my Docker file. It's really that simple. And I took the time to build that base image, and then I took the time to build the dependency image. And so in this case, I think I call this one PySnow. So think about that. We're controlling the software supply chain, right? So with Ansible container groups, what I really like about it the most is it's going to allow us to run playbooks at scale. And I mean, it's amazingly scalable. So have you kind of played around with job slicing within an Ansible Tower template before? If you have, then you probably understand how that works, right? So if you have like a 3-node Ansible Tower cluster and you set the job slicing to 3, then what will happen is it will break up that inventory and across all 3 nodes. That way, your playbook is finished a lot faster. Now, when you start running against large inventories, which we have some customers that run against 10,000, 15,000 devices, job slicing very much comes in handy because you don't want all those getting sticky to one node, right? You want to split that up, and if you're running against that many devices, you maybe scale out your cluster to like 5 nodes or 7 nodes. But with container groups, you wouldn't necessarily really need to do that, because what you can do is you can just have a pod for each slice, right? And so if you think about that, you don't need that physical server sitting there in the tower cluster, right? Or maybe even if it's an isolated instance, like often like a remote data center, if you have a Kubernetes cluster in that data center, right, you can just use this container groups feature and spin up a pod for each playbook run, for each host, and they could all run simultaneously, right, and finish extremely quickly. And the cool thing is it actually scales to 0. So much like a serverless function, if you're familiar with how a serverless function works, it basically fires off, and then when it's done, it scales back down to 0, right? So that's kind of like terminology that we would use in Kubernetes is you can set up what would be called like a replica set, and you can say, hey, this web app that I'm running, I want to make sure that there's always 3 instances, 3 pods running at all times. So if one crashes, tear it down and spin me up another one, make sure I always have 3 running, right? We're going to put those behind a load balancer, and then that way we're always ready. We have redundancy. We have the ability to spread out the load if we have a high volume come in all of a sudden, right? Like maybe a commercial errors or something for a product, and all of a sudden now we got all these requests coming in for people to purchase it or something, right? In some kind of like web app, right? So that's would be like a replica set. But in a serverless function, it actually fires off the container, executes a task, and then scales to 0. So you're saying, hey, if you're not actively running, like as soon as you finish, just scale down to 0. And I'm going to demonstrate that for you. We're gonna fire off an Ansible playbook. We're going to watch 3 pods, right, get spawned, and then we're going to go over to OpenShift and take a look, watch those pods come up, execute, and then go away, right? Get torn back down. And that's really the magic behind Kubernetes, right? It's a container management platform. It's supposed to manage all that stuff for you, right? So think about that. You get a pod for each slice that you set in your Ansible Tower template. So just to touch back on Quay again, because Quay is going to really give us the secret sauce in this kind of use case and in this demo. So Red Hat Quay came over with the CoreOS acquisition. Hopefully you're following along with that if you're in the Kubernetes world. But like I said, it's an open source container registry platform. Okay, so that's where you're going to take those Docker files, and then you're going to kind of, what I do is I actually point Quay at my Git repo, and then it pulls down the Docker file, builds the container, and then it actually scans it for vulnerabilities, right? And so this is really going to be a great feature for us, because for a long time when we were thinking about security with our automation, right? Like of course you can see inside the YAML files that you're writing and make sure there's nothing malicious happening there. But if you think about it, like where would somebody really put something malicious if they were trying to get it into your Ansible automation? Most likely they would put it in your dependency, because when's the last time you actually looked at one of those Python packages? You know what I mean? So one thing I wanted to just touch on here is that Red Hat Quay, it's 3.3 is in tech preview, but what Quay uses is an open source project called Claire, and Claire version 4 is about to kind of come out here. This is in tech preview right now, but within Claire version 4, one of the really cool things about that is not only can it scan for vulnerabilities in the OS, right? So like Claire version 2 does, and Claire version 2 is actually what's running on the software as a service platform that I'm using, right? The quay.io. But if you were to stand this up on a Kubernetes node within your network, right? You could install Claire version 4, and you'd be able to not only scan that base OS, but you'd also be able to scan the Python packages. So you have really, full security protection there. So you can scan that before you even try to run it in your network. You can build it in Quay, scan it with Claire, and get a printout. And then if you're using, like I mentioned, the Quay operators, if you're using the Quay container security operator, any containers that are running that have vulnerabilities, you'll actually be able to see from the OpenShift dashboard. So if you can see my Ansible Tower here, what I have is a template called pod incident. What this is going to do is create a ServiceNow ticket for each Red Hat Linux server that's in my inventory. In this case, I have 3 servers in my inventory. I spun them up on AWS for this demo. So if we take a look here, what we're noticing here, right, is it's pod incident. It's running against the Red Hat Linux servers inventory. I'm using 2 credentials. Of course, I have to authenticate against the Linux server, right? And then I also have to authenticate against ServiceNow's API in order to create the ticket. And if you look over here, under instance groups, I have an instance group that's created called shared cluster with PySnow. And I'll show you, if you were to come over here to instance groups, we can look at the shared cluster with PySnow. Here's that pod spec or the pod definition file in this kind of field right here called pod spec overview. This is what the file looks like, and this is very, if you're familiar with like Kubernetes manifest, this is pretty much what they look like. So in this case, I'm specifying a namespace, which is a Kubernetes kind of terminology. The namespace that we'll be using over in OpenShift will be Ansible Tower, right? So you can have multiple namespaces and you can have permissions and into certain ones. It's kind of a way to kind of segment stuff. And then you have your spec portion of the manifest here. And for containers, this is the image that I'm using, right? So I'm pulling from quayio from my account, Colin McCarthy, and then PySnow pod latest. Now I said like, this is not good practice in production, but in the lab it really helps because I can develop quickly against it. But in production you wouldn't want to use that. And then really this other stuff you don't need to worry too much about. That's just some kind of Kubernetes settings that are in there, some arguments, and just the image pull policy. But really that's all it takes, right, is I set up a credential that kind of points towards my OpenShift cluster, and I fill out a token in there that allows me to authenticate, right, to the API so I can gain access to it to spin up the pods. And then I just come over here and I put in this Kubernetes manifest, right? This is a pod manifest. And this basically builds my container group, right? So it's under the typical instance group section that you're probably familiar with if you've ever built like a isolated instance in Tower. So if we go back over to the template, it's this pod incident one here. So we can see I've specified that instance group. So basically, if we were to fire this one off, so we can say launch here, you can see that because job slicing was set to 3, it did spin up 3 pods. So right here you can see they're getting created. They're starting to run. So each one of these is running the same playbook, just on a different host from the inventory. And we could watch them from here, or we could even dive deeper within OpenShift and start to watch the events that are happening. So you can see here, this was it kind of getting kicked off. It's pulling the image from Quay, creating the container. Here it finished pulling the image successfully. Now it's starting the AWX container job. And so it's running through all 3. Probably just going to take about a minute here to pull down the image, create the container, fire off the playbook, and then scale back down. So we can just kind of hang out and watch it here real quick. And we could also jump over real quick to Tower. So right now Tower is kind of just waiting for the containers to do their thing. But you can see like it gives you this really cool graphic showing you that it did spin up 3 pods, right? And so if you were running against a larger inventory, you could set that job slicing even higher, right? If you wanted to execute against 10 nodes, you could set the job slicing to 10, and you would see 10 pods get spun up on the Kubernetes or OpenShift side. And so we just keep waiting for these. Eventually, they're gonna they'll finish and they'll spawn back down on themselves. But we'll see the status change. Right now, they're still in the running status. Okay, so the first one has terminated, so it finished. Okay, now the second one's terminating. Third one's now terminating, so these will both drop off here. Okay, so now if we look in the Ansible Tower namespace in OpenShift or the project, you can see that there are no longer any pods, right? And so that's what I mean by it scales to 0. So now if we jump over to Ansible Tower, tower shows that all 3 of these finished successfully. So if we were to jump in just like to this top one here, we can actually look at the playbook run on each one. Now we still have that details section that we're used to seeing over here. So that shows us, what time it ran, and it was slice 1 of 3, right? The job template, and hopefully everybody's kind of familiar with that stuff. And then over here, you can see the output. And what I do is when I create the ServiceNow ticket, I just have it spit out the ticket number. So if we were to jump over to, let me take a look here. If we were to jump over to my ServiceNow and we refresh, we should see 3 new tickets that were created here. We'll jump into this top one. Okay, great. Yeah, so right here you can see that it created this ticket, filled out the short description. This ticket was created by Ansible. What I have it do is, Ansible will gather the facts from the Linux servers. I have it just kind of fill out some of those facts into the ticket. One of the facts that I have it fill out here is actually the tower job ID, so 676, right? So if we were to jump back over to tower and go to jobs, and we can look at 676. So this is actually the ticket we were just viewing, right? So that's kind of cool. If you think about this as a broader use case, right? You could have it execute something on the Linux server and then create the ticket. You could do that to 20 of them at a time, right? You could spin up 20 pods, have them all execute, have them all, make whatever changes are necessary, then create the tickets. You could even go as far as, fill out the description and then close the ticket. But think about how just amazingly scalable that is if you're pointing at a Kubernetes cluster that has a bunch of compute power. And then, of course, when you're not running any tower jobs, that compute power is then usable by the rest of the Kubernetes cluster, right? So it's not like you have 20 servers constantly turned on, right, sitting there like isolated instances, often, remote data centers. You can spin them up, execute the playbook, and then scale them right back down to 0. One of the benefits that I can go into right now of, if you were to choose OpenShift to integrate with this use case, is definitely going to come from Quay, right? Because Red Hat Quay does integrate with OpenShift. There's like I kind of mentioned, there's 3 operators currently in place, and one of those operators is going to allow you. It's called the Quay Container Security Operator. Is going to allow you to actually in the OpenShift dashboard. It's going to allow you to see the vulnerabilities that were detected through the Claire scanning in Quay, right there in the OpenShift dashboard, rather than having to actually go into the Quay GUI and see it there. That's kind of where you'd always see it. And I want to hop over there right now and kind of show you what that looks like. I'm not running the Quay on OpenShift, so but if you were, you would have that benefit, right, of that integration. So that is one of the benefits for sure. And then you'd also have the Quay bridge operator, which is going to, whenever you spin up new containers, it's automatically going to integrate with Quay, kind of dynamically behind the scenes. But I did want to show you just real quick, just the files I used to kind of make this happen. So this is that Docker file that I was using. So like I said, I basically just used the Ansible runner base image. So I just used the stable 1.4, and then I bring in my dependency, and then I have just that required command. I also in here kind of have some of the manifests that I had to use, right? So this is the manifest that I would use over in Ansible Tower, right? So this is a Kubernetes manifest. So basically just spinning up a pod in the namespace Ansible Tower from this image right here, right? So I also have the pod manager role, and then this is a role that I used in OpenShift in order to kind of set up some of the permissions for Ansible Tower to kind of function, right? Again, this is a Kubernetes manifest. But what I do want to show you here is Quay. Now you could open an account right now on quay.io and start to store any container images you might have and kind of get some experience with it. But in production, you would run it on-prem and on Kubernetes and get all those integrations and all that security and goodness there. But if we just take a look at my repositories, here's that base image that I was using, right? Ansible runner. So if we take a look here and we look at my different tags, you can actually see the security scan that took place. So right now there's 8 vulnerabilities that are being detected. Now keep in mind, this is because I'm not running it on Kubernetes on-prem, right? It's using sort of an older version of Claire that doesn't have the Python package scanning built in yet. If you did want to use that, then you would have to run it on-prem. But this is like the SaaS version, which just is really great for demos. So here you can see the vulnerabilities that actually came up during the scan. So these are all going to be coming from the OS, right? These aren't coming from any of the Python packages. And it's kind of cool because if you click on them, you can actually get a link directly to this, like the security advisories that explain exactly what they are, and even give you the CVE number for that vulnerability. So that's kind of cool. So if we jump back over here, so you can see those are the 8 that were detected. Now, of course, if we were using Claire 4, we'd probably be able to find some if there were any in that PySnow Python package. If we go back over to my other repositories, that's the base image, right? And then I just have the PySnow pod, which is the one I was using. These other ones were me sort of experimenting and doing some development work, trying to see if I can make them smaller, right, the container images, and also seeing if I can get any of those vulnerabilities removed, right, by maybe updating the OS or whatever I need to do. But in this case, this one is the PySnow pod. So if we click the tags and we look at it, of course, it has these same 8 vulnerabilities that are basically coming from the OS. So one thing I wanted to talk about here that is kind of cool is the way that I have these built is actually I'm just pointing Quay at a GitHub repo. So if I pop over here, if I was to actually update this repo, like even if I was just to update like the README real quick, it will actually kick off a new build of my container image. So like right here, I could just add like a period and then save it. And so that should kick off a new build of basically all these container images that are built from these Docker files, right? So if we go back over here and we jump back into the PySnow pod, you can see right here a new build has kicked off. So if we go to builds, you can see this build right here is getting triggered. You can see what triggered it. There was an update to the readme.markdown file, and of course we just watched that. It just happened right now at 2:38. So there's Git hooks, right? There's web hooks that are going to reach out here and kick this off. So that's kind of a cool feature, right? So if anybody makes any changes to that Docker file, then it's going to just automatically kick off a new build. And so if you had it set to latest, then next time it pulls, it's going to pull this build, right? And that's why it's not best practice to really set that unless you're doing development. But if we watch this, we can watch what's happening here. We can see it building the Docker file, or actually using the Docker file, to build the container image. So you can see right here, here's the base image it pulled from. It ran the pip3, then it issued that command, and then the Docker file build was complete, right? It worked fine. There was no failures. If you had a failure there, it would tell you. So then you can just go back to your tags, and then here we still have those 8 vulnerabilities, right? So a lot of cool features there as far as vulnerability scanning of the OS, kind of also using GitOps, right? A change in any of the state in Git kicks off a new build immediately without any human intervention. And so there are the 3 operators. We won't really go, into demoing them today. That's more of maybe a Kubernetes or OpenShift demo that we could do sometime maybe in the future if you start getting more interested.